Hi everyone, this is your math guru. In this video, I'm going to show you how to apply the Pythagoras theorem and the trigonometric ratio to right angle triangles. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. In the following example, we have in the diagram, ABED is a trapezium with right angles at E and D, and CED is a straight line. The length of AB and BC are 2D and 2 root 3 multiplied by D respectively, and angles BAD and CBE are 30 degrees and 60 degrees respectively. 1. Find the length of CD in terms of D, and 2. Show that the angle CAD equals arctan in bracket 2 over root 3. Starting with the first question, which says find the length of CD in terms of D. CD, because this is a compound figure or a compound shape that's made up of more than one shape, I'm going to break down the length CD into two. I have the length from C to E as my 1, and I have the length from E to D as 2. I'm going to solve them separately and add to get the total length CD. Using the first triangle, I'm going to call that capital A. If I draw it out here, it's a right angle triangle because CED has been said to be a straight line. So if the angle at E is 90, the other angle at E will also be 90 degrees. So this is C, this is E, and this is B. The angle here is 60 degrees. The length BC has been given as 2 root 3 D. Because it is a right angle triangle, I'm going to be using the trigonometric ratio. So labeling my sides, the side CE facing my angle will be my opposite. The longest side is my hypotenuse, and the last side is my adjacent. Because I'm looking for CE, I'm going to be using my sine ratio, which states that sine theta equals opposite over hypotenuse. My theta in this case is my 60 degrees. Opposite is CE, which is the side I'm looking for, over the hypotenuse. That's 2 root 3 all multiplied by D. This sine 60 degrees is over 1. If I cross multiply, I'm going to have CE, which is the length I'm looking for, equals 2 root 3 all D multiplied by sine 60 degrees. If I punch that in on my calculator, sine 60 degrees will give me, I still have my 2 root 3 times D times sine 60, that's root 3 over 2. Simplifying, 2 here 1, root 3 times root 3, that's 3, times D, that's 3D. So therefore, CE, or the length CE, equals 3D. So therefore, my CE is equal to 3D. In order to find ED, I'm going to break down the shape to form another 90 degrees here. Let me call this point F, such that if I draw out the triangle or the right angle triangle I have there, I'm going to have, this is 90 degrees, this is A. I'm trying to draw out triangle B. This is F, and this is B. This is angle 30 degrees, and AB is 2D. Note that the line BF is the same or equal to the line ED, which is what I'm trying to look for. So therefore, if I label my right angle triangle like I did in the previous calculation, the side facing the angle, which is BF, will be my opposite. The longest side is my hypotenuse, and AF will be my adjacent. Using my trig ratio, I'm going to use sine, which states that sine theta equals opposite over hypotenuse. My theta in this case is 30 degrees, so I have sine 30 degrees equals my opposite, which is BF, which I've been able to show you that is also equal to ED. So I'm going to write ED instead of BF over my hypotenuse, which is 2D. Sine 30 here is over 1. If I cross multiply, my ED will be equal to 2D times sine 30 degrees, which is the same as 2D times 1 over 2, that's sine 30 degrees. 2 here 1, therefore my ED equals D. Remember, this is equal to D. I'm looking for CD, and I've been able to state that the total length CD equals CE plus ED. So therefore, CD equals CE, which is 3D, plus the length ED, which is D. Therefore, total length CD equals 4D. So in summary, for the first part of the question, CD equals CE plus ED, which equals to 3D plus D, and that would be 4D. For the second part of my question, it says show that the angle CAD is at tan 2 over root 3. If I draw out my second triangle to reflect my angle CAD, this is angle A, this is angle C, this is angle D, which is a right angle triangle. What I've done is to link the point A and C to form the big triangle, such that the only parameters I have is my CD, which I was able to calculate as 4D. I'm looking for my AD. I don't know what AD is, but if you check the diagram, the distance A to D, AD is equal to the distance AF plus FD. To find AF using the B triangle, AF squared, using the Pythagoras theorem, AF squared equals AB squared minus BF squared. AF is my adjacent, BF is my opposite, and AB is my hypotenuse. AF squared, which is the side I'm looking for, equals AB squared, that's 2D all squared, minus, we've been able to show in the previous question that BF is equal to 2D to ED, which is D, so that's D squared. That will be 4D squared minus D squared, which will give me 3D squared. Therefore, my AF squaring both sides will be square root of 3D squared, which is the same as D root 3. Likewise, to find FD, the line FD is equal to the line BE. So therefore, I know that FD is equal to the line BE. So using the triangle A as shown, that's triangle CBE, I'm going to have BE squared, which is the same as FD squared, equals, using the Pythagoras theorem, CB squared, which is the hypotenuse, minus the opposite, CE squared. CB, which is in bracket 2 root 2D root 3 all squared, minus CE squared, that's 3D all squared. That will give me 12d squared minus 9d squared. That's 3d squared. Therefore, finding the square root of both sides, fd is the square root of 3d squared, which is d root 3. So therefore, the total AD is equal to AF, which is d root 3 plus FD, which is also d root 3. Therefore, AD is 2d root 3. So the total distance AD is 2d root 3. Now to find angle CAD, I'm going to label my sides. The side facing the angle I'm looking for, which is CD, that's my opposite. The longest side, my hypotenuse. And the last side is my adjacent, ADJ. Using the trigonometric ratio, tan theta equals opposite over adjacent. My theta in this case is angle CAD. So I have tan angle CAD equals my opposite, which is 4d, over my adjacent, 2d root 3, which is equal to, I have d cancelled, 2 here 1, 2 here 2, that's 2 over root 3. Therefore, to find angle CAD, I'm going to find the arctan of both sides. So that will be tan arctan in bracket 2 over root 3. Thanks for watching. Bye.